Bring back Visual Studio. If I make a change to this such that I, for example, say minus, and I rebuild the solution, I can now I can attach to the SystemVue process. When I bring back SystemVue, let me re-enable that library. Okay, let's reattach because we had moved that slightly. Now, when I simulate, you can see that the response has changed. I can go back to Visual Studio and set a breakpoint at this place. And when I go to SystemVue and hit Run, it automatically goes to this place in the source code, and I can single step through. In fact, here's the input and output values. Gain, input 1, input 2, and output as, let me arrange SystemVue. Now when I hit continue, you can watch the values change because of the ramp. As the ramp changes, input 1 keeps increasing, and you can see the output values dynamically. When I'm done, SystemVue returns to the user interface. So this is a fairly simple example. This is just a little adder, but it shows how debugging can work for a communications physical error where you may actually be working through a complete modulation example at the RF level, but debugging down at the individual algorithmic level. Within the system, there are actually a few other examples. Let me show that briefly, and we'll set you free to complete the manual. Under Examples, if you go to ModelBuilder, C++, Simple ModelBuilder example, you'll see an example that has 3, a complex adder, an upsampler, and an FIR filter. Each of these is described in more detail in the tutorials in the help manual. I hope you enjoyed this tutorial on the ModelBuilder interface in SystemVue. We built a C++ model, we debugged it, and we looked at several other examples using pretty much free tools in the basic environment. Thanks very much for your time, and good luck with your algorithmic modeling. More information is available on the website at agilent.com. Find ESOF-SystemVue-videos. Thanks very much.